In college algebra, we started 1.3, and it's basically just some word problem practice. So on number 1, on all these, by the way, I would hit pause and read through it before I start working through it. But on number 1, what I would do first is define what each letter stands for. So E is how long a person will live. And T is years, let's say number of years. Since 1950 that a person was born. So it's really important to do that because when they give you a number here in the problem, you need to know what to plug it in for. So 82 is life expectancy, that is E. So up in our equation, I'm going to put 82 in place of E, and I'm going to solve for T. So it's pretty straightforward in that regard. The harder part is making sure you plug in the right number for E, and then knowing what to do with T on the very last step. So I'm going to subtract 7135 from both sides, and I get 1065. And then let's divide both sides by 0.177, and we end up with 60.17. Now we're not done. It said, what year were they born? Use the above formula to determine the year of birth. So what we need to do is add that number of years to 1950. And then we got it. And that looks like that adds up to 2010.17. Let's say about the year 2010. All right. On number 2, I would hit pause and try and think of 2 equations you can write. We have 2 unknowns, dogs and cats. That means we need 2 equations. So the first equation is you need to make sure they add up to the grand total, which is 114.7 million. The other equation in the first sentence, people commonly mix up. So it says cats exceeds the number of dogs by 7.5. So that means it equals all the dogs plus 7.5. It helps to kind of talk through what you wrote and to also read what was typed. And that'll help you kind of do some trial and error in case you write it wrong. What I would do at this point is substitution. Notice how this says C equals that. That means instead of this C, I can put this in its place. I can do substitution. So I can say D plus 7.5, that's in place of that C, plus the rest of the equation. And then I can solve it. We have 1 variable, we have 2 D's. Let's subtract 7.5 from both sides. That's 107.2. Let's half it, and we get 53.6. And there's the number of dogs. We also need the number of cats. So let's add, for cats, I know that this needs to add up to 114. So let's go 114.7 minus 53.6. And I know number of cats is 61.1. All right, we did one more. So this one is pretty dated. I need to retype it, but we can work it. So back in the old days, they used to charge you extra for calling long distance on your phone. So like outside the county, a different area code, they would charge extra. So this thing says, once again, I'd hit pause and try and write the two equations. But this says Plan A costs $20. That's like a flat fee, plus 5 cents a minute. Plan B costs a flat fee of 5 plus 10 cents a minute. And then it asks us a very convenient question: when will the two plans be the same, like cost the same? These two are the costs right here, like the total cost. So why not set the two equations equal to each other? I call this the break-even point. So I set the two equations equal to each other. And then I have one variable, I have an m, I can solve it. Let's subtract 0.5 from both sides. I'm going to write this because you end up getting 0.5. That could be confusing. Subtract 5 from both sides. And we end up getting 300 minutes. So at 300 minutes, the two plans will cost the same. Hope that made sense. I will see y'all later. Bye.